Good day, students. This is Control Engineering Lecture, and I will discuss to you our Module 3. Our topic for today is about block diagram and signal flow graphs by yours truly, Engineer Manager Mandane. And for our motivation time, according to Ecclesiastes 12:1, remember your Creator in the days of your youth, before the days of trouble come, and the years approach when you will say, I find no pleasure in them. And I hope and I pray that you will always remember your Creator, especially na bata pa lang kayo, no? I pray that you will always seek Him and be thankful in everything. So let us begin. What is a block diagram? Well, a block diagram is a specialized high-level flowchart used in engineering. It is used to design new systems or to describe and improve existing ones. Its structure provides a high-level overview of major system components, key process participants, and important working relationships. And it is a graphical presentation or representations of a system. It provides a functional view of a system. Block diagrams give us a better understanding of a system's functions and help create interconnections within it. Block diagrams derive their name from the rectangular elements found in this type of diagram. They are used to describe hardware and software, are described and defined according to their function and structure, as well as the relationship with other blocks. In this topic, you will be able to learn more about the block diagram and how we will do it, and also the signal flow graphs. So, in these topics, why are block diagrams are really important? So a block diagram is an essential method used to develop and describe hardware or software systems as well as represent their workflows and processes. Block diagrams are used in electronics to represent systems and their shiftings, like mechatronic systems in the trucking industry. And the block diagrams are generally used when the visualizations of informations or control flows is important, or when processes are involved. In this way, we can represent complex algorithms or flows of informations or communications among individuals components within a large system, as with, for example, in a facility designed for mass production. A graphical representation is often easier to understand than a textual representation. Okay, what is the block and their properties? So block diagrams describe different hierarchies and connections between individual building blocks within a system. These elements are represented as blocks, dependent relationships among properties, their values, their constellations, and their behavior are described. Block diagrams are suited particularly well to in providing simplified representations of functional processes and of relationships between individual building blocks in the system. The way in which properties and parts of the blocks are integrated can be described in another kind of diagram, which is the internal block diagram. Okay, so what we gonna use, or what are the symbols used in block diagrams? So block diagrams are use very basic geometric shapes, which is boxes and circles. So the principal parts and functions are represented by block diagrams connected by straight and segmented lines, illustrating relationships. When block diagrams are used in electrical engineering, the arrows connecting components represent the direction of flow or signal flow through the system. Whatever any specific block represents should be written on the inside of that block. So a block diagram can also be drawn in increasing detail if analysis requires it. Feel free to add as little or as much details as you want using more specific electrical schematic symbols. So here's the best practices using the block diagram. First, you can identify the system. Determine the system to be illustrated. Define components, inputs, and outputs. And second, you create and label the diagram. Add a symbol for each component of the system, connecting them with arrows to indicate flows. Also, label each block so that it is easily identified. Third is indicate input and output. Label the input that activates a block and label that output that ends the block. And last is verify accuracy. Consult with all stakeholders to verify the accuracy. Okay, so now